You know that feeling, right? You're starting a project or maybe just trying to figure out the data you've got, and suddenly you're facing this just massive list of database options.
Oh, absolutely. It's overwhelming.
It really is. You just think, come on, I just need somewhere to put my data.
Exactly. But, the landscape's exploded for a reason. What works brilliantly for one thing can be, well, a real pain for something else.
Right. And that's why we're doing this deep dive today. We're looking at the article, Why Are There So Many Databases? By Kai Perry Jones.
Hmm.
Think of this as like your shortcut guide. We want to pull out the really key stuff, break down these different types, figure out when you'd actually use them.
And just as importantly, when not to use them.
Exactly. When to steer clear.
Yeah.
So you can, feel like you've got a handle on it without getting totally bogged down in technical jargon.
Sounds good. And the article, it lays out 9 broad categories, quite a few to get our heads around.
9. Okay, let's hear them.
Yeah, so we've got data warehouse, data lake, transactional database, document database, key value store, graph database, time series database, vector database, and finally, multi-model database.
Wow, okay. That is a list. But all right,
Yeah.
let's take them one by one. Where should we start? Maybe data warehouse, what's the gist there?
Okay, yeah. Data warehouses. They've become really central for large-scale data analysis. Think of it like a big central hub.
For reports and stuff.
Exactly. Bringing data together from different systems to run complex queries, find trends, get those business insights. They're built for chewing through huge amounts of typically historical data.
Taking sense of the past to plan the future kind of thing.
Precisely. It's about informing strategy. And the cloud is massive here.
Right. The article mentions cloud options.
Totally. Solutions like Google's BigQuery, AWS Redshift, Azure Synapse Analytics, they're pretty much the standard now.
And it mentioned something about picking the one from your cloud provider.
Yeah, a practical point. If most of your data is already sitting in, say, AWS, using Redshift often just makes the integration smoother, less hassle.
Makes sense.
Huh.
What about Snowflake? It gets mentioned a lot. The article seemed unsure about its future dominance.
Well, yeah. Snowflake got really popular because it was, easy to use and it worked across different clouds, which was a big deal.
Huh?
But the article suggests that as the main cloud providers, AWS, Google, Microsoft have improved their own offerings, made them easier. Snowflake's kind of unique selling point isn't quite as strong, so its growth might slow down.
Interesting. And then there was DuckDB. A local data warehouse. That sounds a bit odd.
It does, doesn't it? Because data warehouses are usually about big data, hundreds of gigs, terabytes, right? Trying to crunch that much on your own laptop with DuckDB, well, it gets tough fast.
Right.
So the article kind of questions, what's the main use case there? It's still a bit fuzzy for those really big problems.
Okay, so boiling it down.
Yeah.
When do you use a data warehouse?
The article's pretty straightforward. If your business really values data analysis, BI, that sort of thing, and you've got, let's say, at least hundreds of gigabytes of data.
Then it's probably the tool.
Yeah.
And when to avoid it.
If you just don't have that much data, it's probably overkill, too complex, too expensive.
Got it. Okay, next category. Often mentioned as an alternative, right? The data lake. Sounds less like a specific product.
That's a really key point the article makes. It's more of an architectural pattern.
Okay.
The core idea is simple, really. Store your raw data, whatever format it's in, structured, unstructured, messy, and cheap cloud storage.
Like AWS S3.
Exactly. S3, Azure Blob Storage, Google Cloud Storage, places where storing data is way, way cheaper than in a typical data warehouse.
The article had some cost numbers, didn't it? That really jumped out.
It's staggering, honestly. Storing a terabyte uncompressed in S3 might be, tens of dollars a month? In a data warehouse like Redshift, it could easily be hundreds.
Wow.
Multiply that by petabytes, and yeah, the savings are huge.
But it can't just be dumping files there, can it? How do you actually use the data?
Good question. That's where the other pieces come in. Modern data lakes use things called table formats. You might hear names like Iceberg, Delta Lake, Hootie.
Okay, what do they do?
They add database-like features on top of those raw files. Things like ACID transactions.
ACID. Remind me. Atomicity, consistency.
Isolation, durability. Yeah, the guarantees you need for reliable data operations. These formats also let you change your data structure over time, schema evolution, and even look back at older versions of your data, which they call time travel.
Cool. So storage, table formats, anything else?
Query engines. Tools like Trino, Spark, or cloud options like AWS Athena or BigQuery external tables. They let you actually run SQL queries or use other languages to analyze the data sitting in that cheap storage.
The article mentioned an example. Revolut. Sounded like they did it well.
Yeah, the takeaway there was how it helped break down data silos. Analysts could access data from all over the company more easily, plus the cost savings when implemented properly.
When implemented properly. Sounds like a key phrase there.
Yeah.
The article mentioned downsides, too.
Definitely. They're more complex to set up and manage than a warehouse. If you don't have good planning, good governance, you can end up with a data swamp.
A swamp.
Yeah, just a huge mess of data that nobody understands or can really use effectively.
Okay.
And some query engines, like Trino apparently, can struggle if an operation needs more memory than the machine has.
And what about this data lakehouse term I keep hearing? Marketing fluff.
The article leans that way, yeah.
Hmm.
Suggests it started as marketing, especially from companies like Databricks.
Right.
The idea is basically a data lake with better, more warehouse-like querying tools and governance built on top. So for you, the listener, think of it as an evolution of the data lake, trying to bridge that gap towards warehouse functionality, but still fundamentally based on that cheap storage principle.
Okay, so you use a data lake when?
When you have massive data volumes where a warehouse is just too pricey, or when you have lots of different data types, maybe messy stuff, that won't fit neatly into structured tables. And if preserving the raw, original data is important.
And avoid it when?
If your data sets are smaller, maybe under a few terabytes, or if you need consistently super fast query results, data lakes can sometimes have higher latency initially. And crucially, if you don't have the data engineering expertise in-house, it's not a simple thing to set up right.
Right, that makes sense. Okay, moving on. Let's talk about the old reliable, the transactional database. These are the bedrock, aren't they?
Absolutely. The article calls them workhorses, and that's spot on. These relational databases, they've been around forever, and they power so many applications we rely on.
Built on those AC properties you mentioned.
Exactly. Atomicity, consistency, isolation, durability. Those guarantees are vital for making sure your data is always correct and reliable. Think about online banking or booking a flight.
Yeah.
You need that integrity.
You really do. And the article seemed pretty keen on PostgreSQL.
Yeah. The author basically says for most new applications, PostgreSQL is the default choice. It's open source, incredibly powerful, flexible, got great support for things like JSON, geospatial data, full text search, all built in.
What about MySQL? Still see that everywhere.
Definitely still very popular. Often it's there because of, legacy systems or just team familiarity. It's what we know. It's perfectly fine for many things. But the article suggests PostgreSQL has kind of pulled ahead in terms of features over the years.
And SQLite got a shout out too, as an embedded database.
Yeah, SQL is different. It's not a server you connect to. The whole database lives in a single file right inside your application.
Oh,
It's
interesting.
super easy to deploy, great for mobile apps, desktop software. The article notes it's probably one of the most widely deployed databases in the world because of that.
Wow. Okay, now things get maybe a bit more complex.
Yeah.
The article mentioned distributed SQL, like Cockroach DB. What's the deal there?
Right, so distributed SQL tackles the problem of scaling a traditional relational database.
When one machine isn't enough.
Exactly. It automatically spreads your data and workload across multiple nodes, multiple machines. This lets you handle way more data, much higher transaction volumes.
Yeah.
Plus, you get benefits like better resilience surviving a whole region going down, and potentially lower latency for users spread across the globe.
Sounds amazing, but I sense a but coming.
Oh, there's a big but. Complexity. The article really stresses this. Managing a distributed system is hard. It adds significant operational overhead.
So it's not for everyone.
Definitely not. You'd only really consider it in specific high-end scenarios. Like,
Yeah.
you've absolutely maxed out a well-tuned PostgreSQL instance. We're talking maybe 5 terabytes or more, super high write traffic. Or you have absolute non-negotiable requirements for multi-region availability or global low latency.
And you need the engineering chops to run it.
You really do. Most applications just never hit that scale.
So for the average application, a standard transactional database is the way to go.
Pretty much, yeah. E-commerce, banking, booking systems, anything needing structured data and solid reliability.
When would you actively avoid one?
If your data is truly unstructured, doesn't fit into tables at all, or if you have some absolutely extreme write performance need that genuinely goes beyond what a single optimized server can handle. But the article makes a great point.
What's that?
Often when people say they've outgrown SQL, it's actually because they haven't properly optimized their database, not because the database itself isn't capable.
Ah, good point. Okay, let's switch gears. Document databases. These were a big part of that whole NoSQL wave, right?
Yeah, they gained a lot of traction around, say, 2010 onwards. The big appeal is flexibility.
Huh.
Instead of rigid tables, you store data in these self-contained JSON-like documents.
So each document can have different fields.
Exactly. Different structures,
Right.
which sounded great to developers who felt constrained by traditional schemas by having to define everything up front.
And MongoDB is the big name here.
By far the dominant player, according to the article. They marketed heavily on that schemaless idea, but the article adds a note of caution.
Oh, what's a catch?
Well, as applications grow, that lack of enforced structure can actually become a problem. You can end up with inconsistent data, making it hard to query reliably.
Like a data swamp, but inside your application database.
Kind of, yeah.
Hmm.
You often end up having to add validation rules in your application code anyway, trying to enforce some structure, which sort of defeats the original purpose.
I see. Firestore was mentioned too, Google's offering, tied to Firebase.
Right. Firestore is interesting. It has features like real-time updates pushed to clients, very handy for collaborative apps and things.
Oh.
But as the article notes from experience, those real-time features can get really expensive if you're not careful with how you structure your queries and usage.
The article sounded a bit skeptical overall, like maybe they're overused.
Yeah, the author sort of suggests that maybe the NoSQL badge on a resume still holds some appeal, you know?
Yeah.
The prediction is their popularity might plateau a bit as people get a clearer sense of the trade-offs.
Okay, so when are they a genuinely good fit?
Good for rapid prototyping, when your data model is really fluid and changing fast. Content management systems often use them well, allowing flexible content types. And of course, if your data naturally looks like varied documents,
And when to avoid?
if the only reason you're picking one is because you don't want to bother thinking about your data structure, that usually leads to pain down the road.
Right. Okay, on to something that sounds way simpler. Key value stores.
Yeah.
Just keys and values.
That's the essence of it. They're designed for speed and simplicity. Give it a key, get a value back, super fast lookups, no complex queries, no joins. The article nails it, comparing it to a persistent distributed Python dictionary.
Like a giant lookup table. And there are different types. In-memory versus on-disk.
Exactly. Redis is the absolute leader for in-memory. Data's in RAM, so it's incredibly fast.
They're fit for caching.
Caching is a huge use case.
Yeah.
Also, session storage for websites, rate-limiting APIs, maybe some simple real-time counters or lists. Redis actually supports a few more data structures beyond simple values, too.
Yeah, and the on-disk one mentioned was DynamoDB.
Right, AWS DynamoDB. It's disk-based, distributed, built for massive scale and durability, but still based on that simple key-value access pattern.
So not quite as lightning fast as Redis, maybe, but handles huge amounts of data.
Precisely. Good for things like storing IoT device logs, maybe game state data, user profiles looked up by ID, simple, often schemaless data where you know how you'll access it by the key.
So quick summary, Redis for speed, caching, sessions. DynamoDB for massive scale with simple, predictable access.
That's a great way to put it. Redis, where latency is absolutely critical. DynamoDB, where scale and durability for simple lookups are key.
When should you not use a key value store?
If you need complex queries, if you need to search data based on different attributes, or if you need to join data together, trying to force a key value store to do that usually ends up being really inefficient and complex. You end up building workarounds that are worse than just using a relational database.
Gotcha. Next, graph databases. These always sound cool, but the articles seem to imply maybe not that necessary most of the time.
That's exactly the vibe. Fascinating tech, but the problems they solve brilliantly are actually quite niche.
What's their core strength?
Relationships. They're designed for data where the connections between things are just as important, if not more important, than the things themselves.
The article mentioned a personal story, right? Trying one and switching back.
Yeah, the author tried Neo4j for a project, but found that ultimately the flexibility of PostgreSQL and its relational features were actually a better fit for what they needed. The specific graphy problems just weren't central enough.
So what are those classic graph problems they excel at?
Social networks are the textbook example: finding friends of friends, identifying communities, influence analysis. Fraud detection is another big one, spotting complex rings of related fraudulent activity.
Okay, so networks and fraud.
Yeah.
And for pretty much everything else.
You're probably better off with a different tool. They're powerful but specialized.
Right. Okay, moving down the list. Time series databases. Highly specialized again, it sounds like.
Very much so. Built specifically for handling data points collected over time. Think server metrics, sensor readings from IoT devices, stock market prices, anything with a timestamp where the time aspect is critical.
And they're optimized for that kind of data.
Heavily optimized. Usually for writing lots of new data, quickly append heavy workloads. They excel at querying data within specific time ranges, often have built-in functions for summarizing data over time, like calculating hourly averages from minute-by-minute data. That's called downsampling. And they usually handle data retention automatically, like automatically deleting data older than 90 days.
InfluxDB got mentioned as a leader.
Yeah, InfluxDB is a big name. It has its own query language, Flux, which the Oracle notes can be powerful but also has a learning curve compared to SQL.
Uh-huh.
And their cloud version can apparently get quite pricey, though the open source one is solid.
But there was another one mentioned, TimescaleDB, built on PostgreSQL. The authors seem to like that approach better.
Yeah, TimescaleDB takes a different tack. It's an extension for PostgreSQL, so you get the time series specific optimizations, but you still have the entire power and ecosystem of Postgres available for everything else.
Best of both worlds, potentially.
That seems to be the argument, yeah. A good balance.
So when do you absolutely need a time series database?
If you're collecting high volumes of metrics, infrastructure monitoring, IoT data streams, financial ticks, anywhere you need to store, query, and analyze trends in timestamp data efficiently at scale.
And when is it overkill?
Just because your data has a timestamp doesn't mean you need one. Most regular databases handle timestamps fine for general application data. Time series databases are really for that high-throughput, metrics-focused use case.
Okay, nearly there. The newcomer. Vector databases. This is all the AI hype, isn't it?
Totally driven by the AI boom. These databases are designed to store and search based on meaning, not just keywords. They work with vector embeddings.
Vector embeddings.
Okay.
Those are the numerical representations of text or images, right? Generated by AI models.
Exactly. Think about how ChatGPT or Claude understand your prompts. They convert language into these dense numerical vectors. A vector database is optimized to store billions of these vectors and find ones that are semantically similar very quickly.
So it's for finding things that mean similar things, even if the words are different.
Precisely. That's the core value.
Yeah.
Semantic search.
Pinecone and Milvis were the names dropped.
Yeah, Pinecone was an early mover, fully managed, API first. Milvis is the big open source player, gives you more knobs to turn for configuration.
And now traditional databases are getting in on the act.
Big trend. Lots of existing databases are adding vector search capabilities. PostgreSQL has pgvector, which is quite popular. For simpler use cases, that might be totally sufficient.
Okay, so use a vector database when?
When you're building AI-powered semantic search, for retrieval augmented generation RG systems where you feed relevant info to a large language model, anytime you need to find things like this thing based on AI understood meaning.
And avoid when?
When you don't need that fuzzy semantic understanding. If simple keyword search or filtering on metadata is good enough, you probably don't need the extra complexity of a dedicated vector DB.
All right, last one on the list. Multi-model databases. The one database to rule them all idea. Sounds tempting, but the article wasn't convinced.
Yeah, the appeal is obvious. Handle documents, graphs, key value, maybe even relational, all in one system, simplify your stack.
But it's hard to do everything well.
That's the main concern raised. FaunaDB was the example given. Ambitious, offers documents, relations, time travel, but uses its own query language, FQL. That's a hurdle.
The learning curve.
Definitely. And the broader worry is that by trying to do everything, these databases might end up being mediocre at each individual model compared to a specialized database.
Yeah.
Performance trade-offs, maybe shallower features.
And integrating specialized databases isn't that hard anymore.
Right. Given how easy it often is to connect, say, PostgreSQL and Redis, the argument for a single complex multi-model system is often weaker than it seems.
So the article's when to use was basically a shrug. Pretty much. The author wasn't really sure of a compelling general use case where it's clearly the best choice.
And when to avoid.
If performance for a specific data type is critical, or if your application overwhelmingly uses one primary data model, in those cases, go with the specialized tool.
Wow. Okay. That was a whirlwind tour. It really does clarify why there are so many different options.
It does, doesn't it? And the article's conclusion is pretty sensible, I think. Don't feel like you need to master every single one that pops up.
Yeah, that's impossible.
Focus on understanding the broad categories. What's a data warehouse for? When might I need key value? Get the basics down.
I really liked that practical advice near the end. For 90% of new projects, just start with PostgreSQL.
Yeah, the minimum viable product database, basically. It's such solid advice.
Keep it simple, keep it reliable.
Exactly. Choosing a database is a big commitment learning, operating, migrating. The boring choice is often the right choice, especially early on. It lets you focus your energy on what makes your actual application unique.
Don't reinvent the wheel if you don't absolutely have to.
Precisely.
And the final, slightly funny warning.
Yes. If someone seriously suggests using blockchain as your main application database,
Run away.
politely but firmly, yes, show them the door.
So maybe the final thought for you, the listener, is to just reflect on your own situation, your current stack, or that next project you're thinking about.
Does the database choice line up with this kind of thinking? Is it the reliable default, or is there a really clear, validated need pushing you towards one of these more specialized tools?
Something to chew on as you navigate this ever-changing database world.